Okay, so we're going to get started. So hopefully you all had a good Labor Day, but still got enough labor in to get your program mostly done. Reminder, that first program is due today, tonight at 11 something or 10 something. I forget what I said. Probably 11. So I do have office hours after class. So if you have particular questions, like you are struggling with this particular piece, come see me during my office hours. But does anyone have general questions about the program? It's only due today, so by now you should have gotten to the point. So documentation for this one's relatively straightforward. I'm looking for you to describe, here is what I did in terms of like my data structure, right? It's arrays, it's not really hard. If you did file I/O of some kind, describe how you represented your file, because I didn't tell you how to have to represent your file. So you have to tell me, here is my file representation, so that when we go to look at it, we understand what it is. If we want to generate one, we have to know what it's supposed to look like. And then obviously your name, right? That's probably the only thing this week. Next, we'll get to more and more documentation moving forward. Also, your documentation should have the name of your Git repo, even though your documentation is in your Git repo. You're also going to turn this assignment in on Canvas. This will be the last time I'm going to make you turn stuff in on Canvas, hopefully. I'll actually decide that next week as the TA tries to grade stuff this week and we see how well it works out. I don't want to miss things because people messed up their Git. I try to put comments in everyone's journal. If you did not give me a Git repo, or if I clicked on your Git repo link and I couldn't see it, then you got some kind of feedback. So if you check your journal feedback, check that, because we do want to make sure we can grade your programs. Right.
Output file for part 2. Are you looking for every single possible combination?
Yes.
I mean, other than repeating combinations like 1, 2, and 2, 1?
So all possible combinations, which means that 1, 2 is not written there twice. 2, 1 is actually formally separate, but it doesn't really matter in this case.
Yeah,
because you're adding. But if I said all combinations, you do 2, 1, I won't care.
Okay.
I probably won't take off from missing it. But if you skip one because it's not valid, well, then we'll care, because we want to see your program say not valid.
Okay.
Any other questions about today's programming?
It's okay if I had the error message output to the new file, right?
Yeah, it's the same thing.
Yeah, that's okay. Yeah. Oh, damn. Oops. Okay, well, if there's no other questions, so I did, well, actually, I'll come back to that. So I'm going to talk now about your next programming assignment. And so your next programming assignment is a little bit different in 2 ways. First, it actually really uses linear algebra instead of just an array. And secondly, you're allowed to work in pairs. You are not required to work in pairs, but you are allowed to work in pairs. And I will talk at the end about some of the requirements about working in pairs. So if you know who you're going to work with and you're sitting next to them, that's going to be fine. I'm actually going to give you a couple minutes in class, like about 4 or 5 minutes, to think about this problem before I talk at all about some of the things you may or may not want to know, because I want you to think through what would you be doing in this programming assignment. So I call this one linear domination. Come on. It's really a stupid game I made up just to do some linear algebra stuff. I don't think anyone will really play this game, but I played a little bit with my wife. It's actually not that bad if you play it. And you play it without a board. If you play it with a board, it's really trivial. It's like playing Othello with somebody who doesn't know how to play Othello, but simpler. So you're going to have a 2D board, so a game board of n by n cells, okay, and it starts empty, like any normal board would be. It's a big grid. Players alternate turns, okay, and a player plays a line by choosing a pair of empty cells specified as start row, start column, end row, end column. Both those cells must be empty. So I have a, well, I'll make it square. 4 by 4? No, okay. 4 by 4. So I could say start at 1, 1 and go to 4, 4. And then I'm going to actually fill in these 4 squares as blue. Right? So the rules are I have to start and end in empty cells. The line I choose to draw must not be parallel to any line that's been drawn before, ever. and I can't use rows or columns that were used in the previous k terms. So k can be 0, 1, 2, 3, 4, however many terms you want. So if I had k equals 1, I couldn't use the previous terms thing, so I couldn't go here because they started and ended in this column. But I could go here or here, right? So there is a little bit of strategy. Don't worry too much about the strategy. You just have to implement the game, not figure out how to play it well. If I were to try and draw a parallel line, so if I were to try and draw this line, right, this would be invalid. Oops. If I were to try and draw this, it would be invalid both because that's in the same row and that's in the same column. But if I was playing with 0, then I don't have to worry about repeating. But this line is parallel to that line. So that would also be invalid play. So you have some constraints on thinking about what do your lines mean in terms of orientation and their angles, however you want to think about those. And then you have to draw, and this is part of what you'll have to do, you have to draw the cells that will be covered by this line. Okay, there's no use of Unity to draw your line for you. You get to draw your line by figuring out what cell should be flipped. Right? So you're going to figure out this is the next cell. And you're going to do that by starting at the highest leftmost point on the line, and then your code's going to figure out what is the next closest point on the line. Okay, so for this line, it was that. Erase them just because the next line can be a little bit more interesting. If I were to try and draw from here to here, it's a little bit more interesting, right? Because there's not, this was a pure diagonal. Turns out the diagonal is really easy. Now I have to figure out, do I go here, 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 or will it go here, 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 right? Depends on how you work through your math, what cells you have to be turning on. But the rule is always move to the next point that is closest on the line of all the neighbors of that point. So in advanced play, which is the only way this game is at all challenging, is you have to play the entire game in your head and state your plays, and then you have the computer score it for you. And then play continues until either player has made an invalid parallel or reused an endpoint play, or no free cells remain. And then the winner is the person with the most cells. Okay? So you're going to make an array for your game board. As I said, you've already seen all the data structures you need. File I/O and arrays. That's all you'll need all semester in terms of fancy data structures. So in this version, right, if you want to do graphics, you can, but we're not grading it for graphics. We want basic file I/O or printing as our display of the board. I'll show you an example in just a second. So say with X's and O's, you're going to define a method for accepting the input. So you're going to read the file of start row, end row, start column, end column. And the file may be longer than is necessary for the game because, especially when you're playing it entirely in your head, people will make mistakes and their play will be invalid and they won't know it yet. So you have to keep playing anyhow. You have to define some representation for a line. Define a method for testing each play for validity. So you have to test, is it not using empty cells? Is it not parallel? Is it not related to previous plays? Define a method for flipping the cells, which is the same as drawing the line. Define a method for computing and displaying the current score, for computing and displaying the score. Define a method to control everything else and basically the outer loop for the game. Okay, you're going to test your game on 5 input files. I've provided 2 now. I'll provide 3 more next week. I want you to think through it before I give you all of the input files. And as well as I want you to design and test it on 2 files of your own. So you're going to have to figure out how to make 2 files. The input file format, this time I am specifying it because we're going to give you some of the files. It's real simple. It's NK, where N is this grid is N by N, and K is the number of plays I have to not use any of the previous cells from. And then just 4 numbers per line for many lines. So it should be very easy to parse. This assignment may be done in a pair or by yourself. If it's done as a pair, you must both upload. I'm not sure about the uploading a zip file. As I said, I'm going to try and do it just with Git, but for right now, I'm still going to say put the zip file. That includes your code and documentation. Either way, you will definitely be uploading your personal statement of who did what on the project and how you feel the grades should be split. Grades on a team do not have to be uniform. If one person did a lot more than the other, we may assign different grades, and so you're going to have to argue a little bit about what that is. Your documentation should include the Git repo for the project, which can be from either of you or from the pair. We will be looking at the Git repo if there's some discrepancy about who did what in the grades. Make sure your name is showing up. If you're pair programming, the two of you doing extreme programming, and you're looking over somebody's shoulder, make sure when they do a commit, your name is, Bob and Dave were working together on this, right? So that we see in the repo that you were actually there doing it. If it just says Bob, did this commit, or Bob's name because it's his account is the only one that's doing it, then we'll say if Bob says I did all the work and Dave did nothing, then we'll believe Bob because the record shows that. So you want to make sure you get a little bit of that in, make sure you get some stuff in. So just to give a little bit, if this was the sample input, 5-0, which means don't worry about previous moves, 1-1-5-5, and so on down the file, then you would expect to see the program print out something like board size 5, cannot reuse row column for 0. That's lousy I/O, but I wanted to make it short enough to fit in the screen, and X goes first. So I'm printing it back out the move, and then the board after that move. So this is showing what happens with 1-1-5-5, 1-5-5-1, and then 2-1-4-5, right, which draws one of these sort of off-diagonal lines and fills things in. So that's the second programming assignment. Any quick questions? I'm going to give you a couple. Actually, we'll say, think about what you need to implement this, and what data structure you would use, how you're going to test lines for parallel, how you're going to draw stuff. Think about that for a couple minutes, and then we'll come back and I'll talk a little bit more about stuff. And while I'm doing this, I'm also going to be calling out a few names. Unfortunately, I don't actually have access to middle initials. So although I asked you to use middle initials in our giant chart last week, it didn't actually differentiate stuff because I don't know whose middle initial is what. So I will call those out in just a second. So Joshua DeAndrea, you're not JD, okay. Well, the other one also, right, there's two JDs, so it didn't really help. Although you're not in the same seat, you guys are messing with me. Andrew Stanek, or ATS. Andrew Simpson? Stanek? Andrew? No. Angelo Salazar. You're over here. Okay. That was you. Owen Chappell. You're over there. Okay. Okay, then some people that did not sign last week. Luke Zinnicker. No, Luke Cole Turner. You were on there? Okay, oh. Okay. 1, 2, 3, 4, 5. Must have missed a row. Joseph Marona. In fact, you're on my list. I must have just forgot to copy it to the right place. Michael Heitzman. You moved. Yeah, okay. Are you going to keep sitting down here? Put you down here someplace. Liam Gunther. Liam. Rachel Lee. Harrison Gerber. Jono Swan. Oh, yeah. You weren't here, but that's okay. Aman Trujillo. James Dugan. And you were here last week too, so I don't know why I missed you. Dirk Dieters. Were you here last week, Dirk? Okay. Ryan Davis. as soon as I'm done checking on name. Ryan Davis. Michael Bolsick. Buslick. MAB, yes. So you were here, just I couldn't figure out what that was. Matthew Briggs. Okay, the other MB, okay. Okay, so I think that gives me everybody. So, Adam Simpson, way back there. Here, ARS, okay. Okay, so now questions, Ryan.
So the game ends once you valid play it's selecting.
Both players making valid play. Part of in the actual strategy of the game, your goal is to leave your opponent no available moves, but to leave yourself an available move so that their turn, they get an invalid play, their turn is effectively skipped, then you get to play. If you can keep doing that for a while, then you can dominate the game. Two invalid plays, them and you. If they mess up and you mess up, then the game's over. You have to fill in every valid point on the line in terms of the closest point to the one before it. Oh no. So if I draw, so if I have this, and the next player does this, right? Then these flip to green. So it's flipping back and forth a little bit like Othello, but not the same rules, right? But I can't put my start point or my end point where they already have a color. So start points and end points have to be clear cells. Everything else flips as you draw your line. Oh yeah, so I definitely want them in text format, right? I don't want to try and read binary. It's really painful. I don't care what the extension is. To me, a text file describes the content, not the extension, right? But if it's a mat file in MATLAB and it's a binary mat file, then that's really hard to read and grade. But for example, do you put like row? So are you writing them out in row major order, column major order? Are you putting all of one row on a line, or are you putting a row semicolon whatever? There's lots of file IO formats you could be using. As long as you specify what it is, we can live with that. As long as we can read it. Yeah, right after another, right? So if you can't make a play, I can't make a play, then the game's over. If you can't make a play, I can, and then you can and I can't, right? Then it keeps going for a while. And that's really a minor set of the rules. It's the only way to make the game have any challenge. Otherwise, it's straightforward, just playing. So, but your biggest assignments are, and so now, does anyone have questions about how are you going to represent your line? What choices do you have for representing lines? Okay, representing the line, the color is not the most important property of the line. So what properties of a line do you need to use in this program? You might want to use slope, right? Because you have to be able to draw it, right? So you have to figure out how you're going to draw the line. So that might need to know like the start point and the slope. Okay. What else do you have to do? There's another linear property you have to test. Angle, are they parallel or whatever, right? So that might work, you know. So now slope is problematic because if I do this, what's the slope? It's infinite, right? So you'll have to not use, I don't recommend, theoretically you can, but I don't recommend you use an explicit representation of your line, right? You can use parametric or implicit, right? Either one will get you where you need to go. And we'll talk next about, so how do you think you're going to draw the line? Anyone thought about what does it take to draw out the line? Where's my line?
Up and then go to the point that's just down to
Well, that's part of what I'm asking. So you have to and I'm going to go through a little bit, but I wanted you to think about what how are you going to do that, right? You're at one way of thinking about it is that I'm at some point in the line. What's the next point on the line, right? So if the line is parametric, I have some idea what direction to go, but if that direction isn't perfectly along an axis, I have to decide which of these points to use. So in any real drawing library, this is an issue you have to worry about. So, Ryan? For testing parallel, if I use parametric form and I use point plus vector, right, then the vectors allow me to decide if they're parallel because the vectors are parallel vectors. How do I decide if two vectors are parallel? Well, I got to remember to take some points here. So two lines are parallel. Right? What property? Well, first, if you've chosen to represent them properly, you can actually just test if they're equal. Because if you use normalized representation, you'll know that they're always the same because you're going to force them that way. But if they weren't, if I just had two general vectors, how do I test if two vectors are parallel? Okay, well, so to be honest, you could actually use the dot product if you wanted, right? Because the dot product tells you something about the angle between them. If they're parallel, the angle is 0. What's cosine of 0? 1. So then I can just use the dot product and their magnitudes and test if they're parallel that way. So there's many ways of doing these things. Lots of things in this class can be done multiple ways. So let's talk about trying to draw the thinnest line of 1 pixel. So in this case, I'm going to use the parametric. This could be viewed as the parametric. The implicit form or the explicit form. It doesn't really matter. We'll go through and use both of them. But if I want to draw this line, this line goes down 1 and over 2, right? So this is not a perfect line to try and draw. So if I have two endpoints on my line, right, I want to write it actually as an implicit function, right? And I have its parametric or explicit form, but I want to write it as an implicit function. So you're going to use that conversion to implicit form, right? And now I want to sort of walk down this line. So if I'm at some cell, right, first I have to deal with the fact that I can only fill in cells, so which is effectively rounding to integers if you want to think of it that way. If I think of these as the numbers 1, 2, 3, 4, and the line wants to be at 1.3, right? I can't be at 1.3. I can be at 1 or 2. So what would I round 1.3 to? 1. So instead of going here, which if I round up to 2, I'd go here. But if I round up to 1, I go here. Right? So that gives me, now this drawing is going the other way around, but you basically take the point you're at and then add 1 to, so I can draw every line thinking of it in one of two ways. Either the line has an x slope or it has a y slope, right? So either I can step in x, but that doesn't work for vertical lines, or I can step in y, which doesn't work for horizontal lines. So I can actually figure out is my line allowing me to step in x or step in y. So I can step, in this case, I can talk about x plus 1, and then ask what is the point on the line. I can solve for the point on the line and then round it to get the next point of the cell. So now we're using our line equation to sort of say, okay, this is the closest point on the line. And then I can do that again. I can add 1 and add, do I go up or down? Right? So I'm going to round up or round down. And then use that to figure out the cells on the line. Does that make sense? So that's the kind of thing you're going to have to do. Now, I'm actually going to talk about an algorithm you don't have to implement, but is actually how almost any library that does real line drawing does it, because it's even more efficient than what I just described. And this is called Bresenham's line algorithm. So if you Google it, you'll find lots of things about it. And the important thing about this, and it was done in the early days, not as much as an issue today, but still in the early days when people were actually playing like arcade video games and these giant things, right? They were all running on just integer processors. They didn't have floating point. The 8086 did not have, sorry, 88 was a floating point processor, came out a little while later, but the 8086 and the 68000 didn't have floating point for them to be using. So all the early algorithms wanted to do everything in just integers because it was faster. And even if they had floating point coprocessors, they were significantly slower, so you try to avoid them. So if I start at the left-end point of my line, and we're going to sort of successively step along the positions whose line is closest to the path. So we have to decide what's the closest. So if again I go back to that formula for the same equation I had just a second ago, so I'm at some value of x. I can actually use the implicit equation to divide the world into two places, or sorry, two halves, right? Because we know from the sign of the implicit equation, right? If our equation is implicit and normalized, the value gives us the distance, and the sign tells us what side of the line it's on. If it's not normalized, it still tells us the sign. It still tells us what side. So if I put in f of x, y, and I put it on one side, it's a positive half plane, then it's positive, right? I'm on this side, and if it's negative, it's on this side of the plane. So I can decide how that is. So if I started with an equation who happen to have all integer elements, and I stick it in, now I can figure out if a particular point, so if I ask the question of the point next to me, right? If I'm here and I ask the question of this point here, is it above or below the plane? And if I can ask this one, is it above or below the plane? I can figure out which two straddle the plane, and the one that has the smaller value will be the one that is closest to the line. Right? Even if I haven't normalized it, it'll always have that property because it's just a scaling. Well, it turns out I can actually even be more efficient. I can keep track of what's called the error, the rounding error. So when I take a step, the error I make when I round we'll call that epsilon. And when I make that step, I can think of that step as the error I made. Well, if I use the same line and I keep making steps after m steps, right, I will have made m times epsilon. Every time I'm going to keep making an error, right? So I'm going to accumulate that error. And so if I track how much error I've accumulated, I don't even have to keep implicitly evaluating the function. That's still expensive. We want to make this efficient. So I'm actually just going to keep track of my running error by doing just addition, and I don't have to worry about evaluating the polynomial. So to handle lines, as I already mentioned, right, you can simply decide if x0 is less than x1, then my step function in x is going to be 1. Otherwise, it's going to be minus 1. Right? And the same is true with y. So either to draw my line, I increment x and I increment y, or I increment x and I decrement y. Right? I don't have to worry about all those. This set of if statements basically lets me decide, am I incrementing x or decrementing x, incrementing y or decrementing y. There is the one case if x0 is equal to x1, then what will this choose? Well, it's going to choose minus 1, but it's going to turn out we're not going to use it anyhow. We'll come back to that in just a second. And since this is a constant line, once I know if it's increasing or decreasing, it never changes. I can just sort of leave it. So at each step, we're going to check to see if the accumulated error has cross points to the other side of the plane, and if so, we're going to step in that direction. So we're going to go through this and basically try and figure out, as I'm making these steps, would the next step make me change from the positive side of the plane to the negative or the other? And if it does, then I need to change that dimension. Okay? And if I do that right, I don't even have to I don't add 1 to x or add 1 to y. I just look at my accumulated error and say, okay, what's going to happen? So let's look at that as an example in C#. I'll actually do this example twice, once in C#, once in Python. So I'm going to decide which direction is steeper. So I'm going to look at the absolute value of the difference in y, delta y, and delta x, right? And I'm going to say it's steep if delta y is greater than delta x, which means it goes up more than it goes over, right? So that's a steep line, okay? And then we're going to use that to decide. So if it's steep, I'm going to basically swap x0, y0, x1, and y1. I'm just going to swap a bunch of variables so that now I can have a consistent way of looking at everything. So now in my code, I've actually swapped x and y if it was necessary, so that I'm always going to view I'm stepping in x, even if I'm really stepping in y, right? Because I've swapped it. So now I'm going to take, I'm going to check if x0 is greater than x1, and if so, I'm going to swap x0 and x1, y0 and y1. So I'm always going to draw my line this way, and if the endpoints were swapped, so the line wanted to go this way, I swap it again. I make it so it goes this way. So that's just making the rest of the math look consistent, so I don't have to do a bunch of ifs. Do it this way, I'll do it that way. So here's the actual line drawing algorithm. I'm going to compute dx. I'm going to compute dy. And I'm going to start with my position error being 1/2 of whatever dx is. My y step is going to be this either one, plus or minus 1, depending on if y0 is less than y1, so if it's going this way or that way. And I'm going to start at the point y equals y0. And now I'm going to iterate over x, and it's going to go from x0 to x1, incrementing x by 1. And I'm going to return a new point as a data structure. So you're allowed to use points, even though I said you don't have to use any advanced data structures. If you want to use things like points in your classes, that's okay. Because while I'm not going to tell you you have to use graphics, if you want to use graphics, that's okay. You're allowed to use points, right? But you can't use their drawing function to draw your line. You have to draw your line. So in this case, we're going to define the point that is either yx or xy, and that's going back to the variable steep, where I swap the variables. So this is the only place I actually need to know is yx or is xy, right, or xx, right? So answering those. Now I update my positional error, because as I was incrementing my step, if I take a step in x, there's an error in y that's driven by this dy value. If that dy value is now changed sign, then I increment my y step and add the position error to x. Otherwise, I'm just going to increment x. I've already incremented the position error for y, and then I'm just going to decide if it changed sign, whoops, then I'm going to step one more time. Okay, and that's really all the code it takes to draw a line. Now that might seem slightly magical if you don't understand how this works, and you want to use this algorithm. I recommend you read through it to make sure you really understand it. Just don't plug it in, because if you do something slightly wrong, you'll get odd results. Just to show it, how many people want to see it in Python? I'm going to try and do examples in multiple languages throughout the semester. So here's the same thing in Python. This time I'm actually putting in some points for the line just so you can sort of see it. Showing out the points. So the initial conditions, I'm going to set up x1 and y1 from the start and end points. Determine my dx, x2 minus x1, y2 minus y1. So here I'm actually treating points as tuples, right? So that's why I can assign them x and y from a single variable. That's a Pythonic thing where I'm assigning elements based on what's inside the tuple. I'm going to decide if it's steep, just like I did in the last one, where I'm looking at the absolute value of y being greater than x. If it's steep, I swap my variables, so I swap x and y. And then if x1 is greater than x2, so if the line's going the wrong direction, I again swap the individual variables, not x and y, but start and end for each of the two, and mark them as swapped. I calculate my differentials, just like I did in the C#. I look at the change between the delta x and the delta y. I calculate my initial error, and if I'm stepping in y, positively or negatively. Sorry, that's a weird, that word start and end is actually all one Python comment. I don't know why it wrapped in PowerPoint. Y equals y1, make my array of points empty, loop over x from the range x1 to x2 plus 1. I'm going to define my coordinates if if it's steep, otherwise I'll define it as yx, otherwise I'll define it as xy. So again, this is a Python way of writing a weird if statement. I am going to append my points, so I'm making a list of points. Decide my position error, again, incrementing it based on the absolute value of dy. Decide if I've crossed to the other side of the plane, so is it change sign for my error? If it is, increment y step, and then increment the error by whatever I would add in x, and then keep going on. And then if I had been swapping the points, then I actually reverse them to put them back in the right order. So that's two different versions of the Bresingham's line drawing algorithms. Any questions on that? Okay. You do not have to use this if you don't want to and if you don't understand it. I can put this entire PowerPoint on there. The video is definitely online, which reminds me I forgot to mention that, so glad you asked. Let's go do our first clicker question. Okay. Well, I go find the other thing. And Hannah, email me the number that's on it. Your 14-day free subscription has expired. Okay. And again, email me the number that's on it so I know who to give points to. So, and I messed this up, so I apologize for that. So, so in our course content in the modules, right, there's the videos you should be watching each week for what's going on. I added a video for how to use Git in Visual Studio. I actually made my own video, but for some reason YouTube rejected it. I don't know why, so I have to repost it. They said there was a copyright violation. It's like I have no idea what happened. Maybe I had music playing in the background and it heard it or whatever. So, yeah. So and there's a couple other videos. So how many people are using Eclipse in Java? I will also find and post a video on how to use Git in that. So you're welcome to use whatever you want. My video was how to use Git on the command line because that's the way I've always used it, which is probably not the way most of you are going to do it. So I'll post some other videos here for how to use Git effectively in this. And program 2. I forgot to turn it on, so I'm going to do it before I forget. Okay, so okay, last call for the clicker, and now we will switch over to chapter 4. Okay, so now I'm going to start doing questions from chapter 4. And I think I forgot this last time, but before I go through clicker questions, I like to start with, did you have any questions? So I did see the questions people wrote in their journals. A couple of comments about that, right? Many of you are still forgetting to tell me the answer you believe is the correct answer to your question. If you do, this week you lost a point. Next week you'll lose 2. I want you to actually show me that you know how to solve your questions.
So I forgot to include Sunday.
Okay. No, you lost. So this week, for being late, you lose a point for the first day, and then I think it does a point a day after that or whatever. So no, you're not host. Okay, send me mail so I don't forget, and I'll go back and look at it. Bolding it might have just, like, depending on what I'm doing, because I actually listen to things a lot. It's really hard to hear bold. So I might not have noticed it, and it's not hard for me to go back and fix it. So again, if I make a mistake like that, please, point it out. Like if you did something like you somehow bolded it or made it italics, I may or may not notice. My goal is not to take off points, but there were still at least 10 people whose answers to their own question were incorrect. Okay, so this is not like just a pointless exercise. And I also want to caution you. I made some comments in various journals. There are people that are referring to material that are not what we're doing in this class. I don't know what you're doing, where you're doing cross products. Maybe it's in Calc 3, maybe it's in physics. Maybe you're just really excited about this class and you've read ahead to chapter 8, but I doubt that. So please stick to your journals relating to the materials we've been doing in class. Now, if you want to relate it to your programming frustrations, that's okay, because that's clearly related to this class. But otherwise, your question in the journal should be something that you struggled with based on this week's work, not the first week's work. We had one more question on global and local transformations, which is not what we did in the last 2 weeks, and not about chapter 8, right? So keep your questions are, and I'll start taking off points next week because I didn't explicitly say that last time. And I'd like to see your journal, your journals. I mean, understanding what you're really struggling with helps me. I change what I'm doing in class based on that. So I've put some in. But any questions from the material in chapter 4? Okay, I'll go through an example of that in just a second, just to make sure.
I'm trying to understand the form for shearing and matrix in one axis.
Okay, I will make sure I cover that too. Since that was in your journal, I put that in here already. In the back. Yes. Okay, send me a mail to check, but if you're one of the people that talk about like the cross product, that's not chapters 4 and 5 of the current edition of the book. So just send me a mail so I don't forget. No, so the videos are from last year, and I was doing quizzes in class. Now I put the quizzes online beforehand so that you had, so I don't have to do them in class. Yeah, there will be no I don't know, there might be 1 or 2 in-class quizzes, but right now I'm not planning on them because I don't find it the best use of class time, but we'll see. So actually I'm going to skip that for a second. Let's talk about how to do matrix multiplication, since that was one of the questions, right? So there's lots of ways, 3 or 4 different ways, to really look at how to do matrix multiplication. So the book's way, and lots of courses in linear algebra, we'll view them as I'm doing dot products of a row times a column. So by laying them out this way, if I want to multiply A times B, I lay them out this way, where A is first, because I'm multiplying A times B, but B goes above it and allows me, point with the mouse, right? A goes on the left-hand side, B goes above it, and then this row is dotted with this column to give me that cell. Right, so, and by dotted, I mean I do the dot product, which is A11 times B12 plus A12 times B22. Right, I'm doing the dot product of this row and this column. And where they intersect is where I put the answer. Okay, so if you write them this way, it's not, I mean, you can do it as just algebra, which is you say this times this, but this will visually help you lay it out. So if you're more visually oriented, this will probably be easier for you. So that's not what I wanted to have come up. So if I'm multiplying a 3 by 6 by a 6 by 4, what is the size of the output? Well, I've already written the answer here. It's 3 by 4. There are a couple of people that also had some problems with this. Okay, I can't multiply arbitrary size matrices. I can multiply them only if their inner columns the number of columns of A is the same as the number of rows of B, right? And if you think about sort of drawing them this way, it makes sense why they have to be that way, right? This row times this column gives me this. Well, if I had more columns than I did rows, then I have one item left over for which there's nothing to multiply it by, right? They have to line up because I have to multiply them pairwise and add them up, right? So I have to have those two line up. Any questions then about matrix multiplication? Yeah, for those of you who've had this before, that's easy. So now let's do a practice one. This one you should be able to do on your own. What is the product of those two matrices, a 2 by 2 and a 2 by 1? I'm also, by the way, I'll make a comment. I'm being pretty lenient in your clicker questions. If people mess up rows and columns and they do funny layouts, as long as I can understand probably what you meant, it's okay. Oh, sorry. Okay. Can't see how much time we have left. I'll give you another 30 seconds. We'll go to about 2:15. Okay, last call. And most people got this one correct. The correct answer is A. Okay, again, I just write A over here, B above it. I do the dot product, which means I take 20 times 10 plus 5 times 15, right? Which gives me 275, and I take 2 times 20 and 3 times 15 to give me 85. Okay? So I will tell you now, when we get to the midterm, there will be at least 2 matrix multiplication questions. If you get either one of them wrong, you get a 0 for the midterm. So if you're struggling with how to do matrix multiplication, practice it. Okay. Now, if you get a small algebra error because you decide that 3 times 15 is 30 for some bizarre reason, right? I'll probably still give you credit. You won't fail the midterm. But if you do something like multiply the matrices by multiplying them element-wise, the Hadamard product, right? You will not do well, right? So I can't have people graduating from this class not able to multiply matrices. It's not like 80% is good enough and you somehow get through. You must be able to correctly multiply matrices. So if you're struggling with these, practice some more. If you need some practice problems, you can generate a program to actually give yourself practice problems, or I can give you some practice problems. Okay, so some now very simple questions. This one, you have 30 seconds. What is the transpose of this matrix? Ten seconds. Okay, last call. Okay, so most people got this. A few of you did not, which is itself somewhat troubling. So the transpose of a matrix is to swap the rows and columns. So if I swap this, I get the answer of A of 3364. Okay, those of you who did not get this, you need to really make sure. Again, transpose is something we can't have you struggling with what is the transpose. It's going to show up all over the place. Now in the book, there's notations that I want to make sure you get. In the book, they try and use M superscript T, or a little T bar, right, to mean transpose. In other linear algebra books, they will unfortunately use the prime symbol, like which I guess I should put that in here. Slides that way. So in other places you'll see it as M prime, and I want to apologize. In somebody's journals, I think it was Hannah's, you asked about the use of prime. I'm not sure, maybe it wasn't you, but and I thought, well, we don't use prime to mean derivatives. In this class, we're not doing derivatives. There'll be one time later in the semester when I talk about derivatives, but we're not using derivatives. So M prime is never derivative, but sometimes it means M transpose, because doing superscript T when you're working on a traditional typewriter or just plain ASCII text is too much of a pain. So people use prime to mean transpose. And I'm not positive if this book does or not. I have so many books I sometimes get messed up. But transpose, you take it and you flip it around its main diagonal. Rows become columns, columns become rows. So if you did something like C, where you had 6, 4, right, that's sort of a rotation, which is an operation on a matrix, but not one that we ever do in linear algebra. It's some odd operation. And D is swapping rows and columns. Again, that's something we will do later on, but it's not what's called transpose. Okay. So we're going to make you struggle with this one, Ryan, but we're going to come back and deal with it. So what is the shear that achieves V? And this is the other use of prime, just to make sure you get properly confused. Sometimes we'll just use prime, which is the primary way I think it's used in the book, to mean a variable other than the one I started with. So if I want to shear V into V prime, now meaning it's just a different variable, how do I shear this value into that value? Now this is a really advanced one, because in the book you almost always sheared something onto an axis. This is shearing something that's not ending up on an axis. So I want you to think about this one, and you can definitely talk with a partner. Oops. I'll give you another 30 seconds. Okay, last call. Okay, so most people didn't get this. The correct answer was B. Okay, and I'm doing this one. It's not quite the way the book asks lots of its questions because it talks about shearing to this axis or shearing to that axis. But in the journals, lots of people said they really don't understand what is a shear. So I wanted to do a very general question. So a shear is any transformation that only changes one axis and leaves the other axis alone. So if I'm going to shear, in this case I drew this one out because this is the, if you think about it graphically, maybe it'll help you understand why it's called a shear. So if I started, I have the point 2, 3, right? And I want to go to 2, 7, right? So I want to find some matrix. So if I have 2, 3, I want to find some matrix A that I multiply by 2, 3 by to get 2, 7. Now, I can look at this graphically and I say, oh look, this axis, the y-axis, doesn't do anything, right? So, sorry, x-axis. The x-axis is here, right? So the 2 goes to a 2. So just from looking at that, what do I want to multiply this vector by so that the first item stays a 2? 1, 0, right? And that's characteristic of a shear. A shear will always have one of the two off diagonals in 2D, a 0, right? Because that's the axis I'm leaving alone, right? And so the other one, I have to figure out what's the combination of 2 and 3 to give me 7, right? Which I get as 2 times this and 1 times that. Now, is that the only combination that gives me 7? No. Okay, so why can't I use any of the others? I heard you, I saw you lip something. Well, they could be negative. So at a certain level, the answer is if I just wanted to find a matrix A that I multiply this by to give me this, I could use anything that gives me this. Any combination on the bottom row would be a valid matrix A, but it wouldn't be a shear matrix. A shear matrix has to have these two items equal to 1. And then one of these is 0 and one of them is not 0. So as soon as I say this one has to be 1, now I'm left trying to solve this by saying, okay, I have, if I think of this now, I have a matrix that looks like, let's call this D, 1, 0, D, 1, right? And I have 2D plus 3 equals 7. I put this in and I put it in this equation and get 2 times D, sorry, D times 3, 2 times D plus 3 times, plus 3 times 1 equals 7. Now I can solve that for D. And D equals 2. So that's the way you can go about solving this once you understand both what is a shear matrix, and then I don't have to shear things to the axis. Now, pragmatically, I might have actually wanted to do that because I might have had some point here that I wanted to shear to this axis. When we do Gauss elimination, we want to put them on axes to make them easier to work with. But if I shear this point to here, this point has to go here. Because in fact what shearing is doing is it's taking what used to be this square and turning it into a parallelogram. Hence the word shear, because I'm keeping two sides straight, just shearing the others, like I might if that was a solid material. And when I do that, this one's going to do the same thing. So this point will shear up to here, and I'll have a different dimensions. So hopefully that explains shearing a little bit better. We'll have another one just to test your understanding a bit. Another quick engagement question. Not enough to worry. Okay, last call. Which of the following is not one of the lecture examples of a matrix property? So, terminology, which of the following is not a matrix property? And this one should be done on your own. You don't need neighbors to make sure you know all the terminology. They won't help you read. Okay, last call. Okay, I'm going to start calling up people because we're doing terminology questions. So, Dakota, what is matrix multiplication commutative or not? It's non-commutative. B times A is not in general the same as A times B. Right? In fact, for non-square matrices, sometimes I can multiply A by B, but I can't even multiply B by A. It's not like they give the same numbers. For square matrices, you can always do it, but they don't always give the same answers. And there's only time they ever give the same answers is if they're both diagonal matrices. Then they will give the same answers. Or if they're the same matrix, all constants. There's a few other special cases. Okay. Kyle Bush. Is matrix multiplication associative? Yes. So what does associative mean? Tell me where to put some parentheses. So that's associative. A times B times C can be done as A times B, quantity times C, or A times quantity B times C. Either one of those works. Okay. Chris, distributive law, true or not? True. What does it mean? Okay, it's actually AB plus AC, not BA. that would be, swapping these would be very different. Okay, so D, matrix multiplication by a zero matrix. Forrest. No, Forrest. William Forrest. That's the name over there. Okay. Leonardo? So, any matrix A times the matrix of all zeros equals all zeros. Not a very deep property, but not all the properties that held in normal algebra hold for matrices, so it's good to know which ones do and don't. So the answer was E, none of the above, because they were all properties. Okay, what's your level of understanding so far in this class? There are no right or wrong answers to this one. Actually, there is a right answer, but... Darn, we have no experts. I was hoping we'd have one. But okay, last call. Okay, so the correct answer for this was actually E. This is not related to the videos because it's supposed to be the most relevant. No, I'm just joking. This is just for me to keep track of where things are, where people are. For those of you who answered D, okay, maybe stop by my office hours, right? There's a lot of material in this class. The most important thing is you keep up. There's a ton of terminology. If you didn't have this in high school, right, you will fall behind. Oddly enough, if you had it in high school, you might still fall behind because all of a sudden we'll go from this is stuff I knew to this is stuff I've never seen and you weren't paying attention. And all of a sudden we'll catch up on that. So, but that's about where I expected things to be. What is the product of these 2x2 matrices? Do this one on your own. Another 30 seconds, still 2 minutes. Last call. Okay, so most people got this. There are a few people who were initially confused choosing A. So A is not the correct answer. A is what you get if you point-wise multiply each item by itself. That is not how you do matrix multiplication. For the people who got D, I have no idea how to get D. It's the wrong shape. Right? A 2x2 matrix times a 2x2 matrix, right? The two middle numbers cancel each other out. It's a 2x2 answer. You can't get a 2x1 answer. So maybe that's like if you, I guess, so the correct answer, by the way, is C. Right? So maybe, I guess, if you add 9 and 7, you get 16. Okay, maybe the numbers were there to tempt you in some bad way, but D was not the right answer. I also don't know how to get B. Let's see, I can figure out how I made up B? I don't see how to get B. The correct answer was C. Again, if you write them A times B in this sort of 1 over the other form, and you just do the 2 times 3 plus 3 times 1 where they come together, gives me 9 and so on, right? That's how you do matrix multiplication. So if you struggle with that, you really have to get over this. Practice it some more. Okay, a road has a bridge over a river at some point along it. The road has the coordinates 4, 2. It's in Nevada. It's a straight road, and has a vector 3 minus 3. The river has the coordinates. It's actually a wash. There's no water in it. It's just a straight line with coordinates 4, 8, 14, 8, and a vector 2, 6. Find the intersection point. You can talk with the neighbor on this one if you're struggling. How many people have absolutely no idea how they're trying to solve this one? It's a lot of people just randomly looking around. So what do you know from these two lines if they intersect? They have a point in common. Okay, so one way of trying to look at this is, how do I say that those two lines both have a point in common? Point where they're equal to each other. Right? So if I set one line equal to the other line, I can try and solve for the variables that let me say they're equal to each other. Any other ways people have thought about trying to solve this one? So you could also convert one of them to implicit form. Given you have it in implicit form, you could stick the other line into it and say what point on this line is equal to 0 in the other implicit form. So there's two ways you can work through that.
So the two equations, one and one, which is don't know why the other equations is this one.
So if you think of your equations, you have an x and a y. So you have a 4 plus 3 times 3. And then you have 2 plus minus 3 times 3. So the top row and the bottom row, they each give you an equation. So P is like two things stacked on top of each other. V is stacked on top of each other.
So we can convert something like this into two different equations.
Right. Okay, I'll give you another, oops. Give you another 30 seconds. Okay, last call. Okay, so who wants to defend the answer E? They do not intersect. 17 people answered that. No one wants to defend it. I might actually give you points if you can correctly defend it. There is a defense for that one. Oh, no, there's enough information. Yeah, okay, there we go. So you get a point for that. Because I described it as a bridge, and a road. There's a bridge over a river, right? That means they don't intersect. The bridge goes over. So, but you're the only one who gets a point for that. Everyone else who got E gets the answer wrong. The correct answer was B from the math. Like, on a map, they will look like they intersect. So they're straight lines. We're going to do the intersection problem. They might intersect, yes. That's right. Okay, so you solve this by basically taking the two equations for the line. Right, so I have 4 to 3 minus 3. If I view it as a parametric line, that's P plus T times V. So I'm going to write that out as two equations. 4 plus 3 times T1, that's my variable for the first one. 2 minus 3 times T1, that's the second equation, the X and the Y equation. On the right-hand side, I do the same thing with the second line. And after that, I now have two equations and two unknowns. There are many ways of solving that, because one of the things you can do is you can use chapter 5 where you learn how to solve it with Cramer's rule. You could have done it that way. Don't have to in this case. In this case, I'm just going to use the straightforward. I'm going to add these two equations. Why? Because I'm lazy and I looked at this and said, oh look, there's a 3 here and a minus 3 here. When I add those two, they go away. And then I get just an equation in T2. When I'm working with linear equations, I'm allowed to take any combinations of rows or columns if I do stuff later, but I can take any multiple of rows and add them together and I don't change the solution. So when I add these two rows, I don't change the solution. So now I get 6 equals 22 plus 8T2, and the rest after this is just algebra, which is just a little, put it all together, so I get minus 16 equals 8T2, T2 equals minus 2, and now that I know what T2 is, I go back up to the original equation, which is this thing here, 14 plus 2T2, and and I stick that in, and I get 14 minus 4 equals 10, and 8 minus 12 is minus 4, which gives us B, 10 minus 4 as our answer. Okay, so if you got the basic idea of how to do it and then you just mess up on the algebra, well, that's just you'll lose some points if we have those as questions and a little bit of practice. Anyone solve it a different way?
Well, I drew the lines that way, so it's really interesting.
Okay, so that's actually another, so if in a multiple choice question, that's actually a really good way of approaching this. If I just draw, I'm not going to go ahead and draw it, but you can really just draw them out and say, okay, here's a point, it goes this way, here's a point, it goes this way, right? Where could they possibly intersect? And I made it a little tricky because depending on how well you draw your graph, 12, 6, and 10 minus 4 are close enough that you have to really be careful about what you're doing, but you can easily solve this one entirely graphically and get your intuition. Okay, in fact, it's also multiple choice. You could have simply guessed them, right, and stuck them into each of these lines and say, are both points on both lines, right? And you'll quickly find out the answer. But the right way to do it is to think about how to solve it, though it's good to have your intuition or a secondary check to say, okay, this is what I think the answer is. If I solved it algebraically, I might still go to figure out the geometric version. Okay, real quick one, 30 seconds. What is the size of a matrix when you multiply a 3 by 2 by a 2 by 4 matrix? Okay, E is a statement about the actual answer, not your abilities. Okay, last call. Okay, so the correct answer, which almost everybody got, was C, 3 times 4. Right? Again, if I want to multiply things, the number of rows in, I basically get rid of the middle thing, so I have 3 rows by 2 columns times 2 columns by 5 rows, and I get a 3 by 5 matrix, right? Or 2 and 4, or whatever. A number of people answered E. I tried to give you a hint there. E, right? I don't know how, the only way to think about E is you don't know how to multiply matrices, so you're going to go guess for none of the above. But. Okay, quick engagement question. Forgot to stick in the, probably okay. Okay, last call. Okay, one more really quick and easy one, 30 seconds. Size of a matrix, 3 times 6 and 6 by 7. Last call. Okay, so the correct answer, which almost everyone got, was D, 3 by 7. 6 by 7, right? That's just the size of one of the two matrices, right? The final product does not have that size. Okay, what is the size of the matrix when you multiply a 3 by 42 and a 3 by 42 matrix? This is quick again, 30-second question, so. Last call. Okay, I think we have some random guessers here because we had an A and a C. Anyone want to justify either A or C? I have no idea. That's just random guessing. They're not paying enough attention. So the answer is E, cannot be done, right? You can't do this, so the answer is none of the above. Okay, so assuming that I've already been trying to solve some point of an equation, and I found the first two coefficients of a line have minus 13 and bx2 equals 10. So I have an implicit line. What must the value of C for this implicit line be for this to lie on the line? Oh. 30 seconds, you should be able to do this one on your own. These are quick repeat questions. This is really from last week. Okay, almost everybody's got an answer. Last call. Oh, seeing some movement here at the end. Okay, so class was pretty equally split between two answers. I'm not going to tell you what those two answers are, but think about how you're going to check your answer and chat with your neighbor to decide if you agreed or disagreed, and we'll try this one again. Okay, last call on this one. I'll give you another 30 seconds. I don't want to have a few people to answer. We already did this question once. I figured this would be pretty quick. But okay, so Patrick, Hannah, Patrick, how do you answer this question? Patrick? Maybe that's not Patrick. Okay. Brennan. You don't know how to answer it. Okay. Mimi, can you help him? Right, so we've given you A and B, and you know that AX1 plus BX2 plus C equals 0. Right, so you now just have to figure out what is C. Okay? It's still open, by the way. I just... Okay, that is helping. Using the right formula helps. Okay, last call. Okay, so yes, knowing that AX1 plus BX2 plus C equals 0, right? You now solve for C. You know A and B plus C equals 0. C equals, moving to the other side, C equals 13 minus 10 is 3. So to get C, you have to somehow add them. To get D, you have to subtract them. But they have different signs, so that doesn't really work. And A is you just got the wrong sign. So. Okay, if the angle of incidence when the line is at 90 degrees, sorry, that doesn't look like proper English. If the angle of incidence with the line is 90 degrees, it is a blank type of thing. This type of projection is very important in linear algebra. So this is just a terminology question. Quick, you get 30 seconds. Okay, last call. "90 degrees is what kind of projection? Last call. Okay, well, most people's intuition or reading, sort of remembering of that worked out pretty well. The correct answer was an orthogonal projection. Right, 90 degrees is orthogonal. Okay, question from somebody's journal entry. Do transformations such as reflections, rotations, and shears change the overall area of the object being transformed? Do this one on your own. Okay, last call. 10 seconds. Okay, so the correct answer was E. No, shearing sheet, no. Correct answer was D. None of these affect the area, so shearing, reflections, and rotations don't change the area of the object. Quick engagement question. We're going to take a break. Be back by 1/4 of.